Welcome to your first video lesson in Universal Physics. This lesson is going to be all about constructing appropriate data tables for use in our experiments. Let's take a look at a specific experiment here. We have a scientist collecting data on a man who's going for a jog. The scientist collects data at 4 separate time intervals and then measures the distance that the runner has traveled once he's reached each one of those time intervals. You'll notice the picture above is sort of like a snapshot or a comic strip of our runner as he makes his way through the time. The first thing that we need to do once we get an experiment is to determine what is our independent and our dependent variable. In this instance, the scientist has control over which times are selected. So that means the scientist is controlling it. It is our independent variable. That means that the thing that changes based on changes in time is distance. So that's going to be our dependent variable. This information is important as we move forward. So then I have 8 pieces of information that have been collected. How do we want to organize these? Having them just thrown all about on a notebook page is not really the most effective way to begin to organize or to communicate what we've found. So, we have a number of different ways that we could attack this. The first is to use lists, sort of like what you see here. Now, these could be effective if we only had 1 or possibly 2 pieces of information. However, we have 4 here, and in many of our experiments as we move forward, we'll be in the neighborhood of 12 to 15, possibly even 30, up into the hundreds of pieces of information. So a long list like this probably isn't the best way to look at it. We could also use what are known as ordered pairs. You might be familiar with ordered pairs from math class. It's basically looking at the 2 coordinates of our information, shown as the independent variable versus the dependent variable. In this instance, that would be time, comma, distance. So we'd see this layout. Now, this does give me a better understanding of how my pieces of information are interrelated, but still, if I get a lot of information, it can become very cumbersome to make my way through lists and lists of ordered pairs. So what we're going to look at is creating a data table. Now, you'll find that this data table here includes all of the necessary pieces that we need or we want to have when we create our own data tables. So let's look at some of those specifics, data table basics we'll call them. The first thing is we have at least 1 column, or I should say we have 1 column for each of our different variables. You'll notice that the first column is going to be our independent variable, or time in this instance, and our second and then subsequent columns will be our dependent variables. In this example, it's just distance. You'll notice our number of rows. We have enough for each set of data. So I have 4 rows for my set of data, or my 4 sets of data, and then I have 1 additional row for my headings. Again, my columns, I have 2 columns because I have 2 variables. Some other things to try and keep in mind. Number 1, our headings. The heading should include the name of the physical quantity and the units with which we measured them. You'll notice here we have time, which is measured in seconds, and distance, which will be measured in meters. Following up on that, you'll notice we only have units in the heading. You'll notice that they don't follow all the way down. Why is that? Well, because if it falls under that heading, it is assumed that each one of those values is measured in that unit. You'll notice that all of my lines are straight. It seems really easy to make that happen on a computer. However, for the first couple of investigations, you'll be required to use a ruler or a straight edge and paper to construct your data tables. You'll also notice there's only 1 value in each cell. We don't have multiple pieces cluttering our ability to see what's going on in our data table. And then finally, we have the same number of decimal places in each cell. This allows us to be as exact as possible but shows that we are being definitive as we make our way through our lab. So, we'll be looking at visual representations of this data in our next video lesson, but if you have any questions about how to construct a data table or a proper data table, please make sure that you ask your instructor.